Hello, everybody. I need this microphone because there's so many people in the room. Who's been here before? Cool. And I'm assuming you're new. Did you take a picture and put it on Twitter? No, not me. You can though if you want. The view out there. It was a beautiful view. What filter did you use? Standard filter. I've never used a filter. I don't know how that works. Ah, welcome. No rush. That's all right. I'll just stand here. So, for Elliot's sake, my name is Perry Dybel. I like to wear really colourful shirts. For anyone who's been here before, my name is Simon, and Perry likes to wear really colourful shirts, but I thought, as I'm in his stead, I would wear an awful shirt. So, Perry is the guy on the left. Rishi is the guy on the right, looking pretty hot. So, as some of you may know, oh, by the way, I've got a plate of notes to keep me going. I've turned on Hangouts of Air, turned on the microphone. You haven't done the lavalier, turned on the camera. Perry, so he's not very well. You may know that he delayed this meetup because he was having a major anniversary with his wife and had a holiday in Spain. And it's amazing how hangovers take a bigger effect as you get older, because his relationship is more with beer than with anything else. So he's not here today, unfortunately, but I'm sure he's tuning on Hangouts on Air, so hello. But I'm better than Perry, so you're in great hands. Two things before I let Jonathan come up on stage. The tag. Anyone know what tag stands for? It's a great TLA. Yeah, if you read it out, you'll win. There's prizes. Anyone know what the technical architecture group do? Anyone who's not Jonathan? Taug. The Taug is a really cool group of people with Tim Berners-Lee in the middle, and there's Daniel Appelquist and Mnot. These are the people who kind of define the future of the web and hope that browsers catch up. And they're having a big meeting on the 26th. Yes. And afterwards, they're having a Q&A session for the public with free admission for anyone to come and have a chat and have a beer with them, which is cool because how many times do you get to meet those kind of people? So on the 26th, put in your diaries, there's a QR code there. People in Japan know how to use them. If you search for Meet the Tag 2017, it's the third link down. And it's on Tito, the ticket website. Not Ticketmaster Universe again. Sorry, Perry. Anyone got it? Number one. I'm an influencer. The second thing I want to talk about is the 1st of August. We have a meetup scheduled, but we have no one speaking at it. And if I carried on for another 45 minutes, you'd all leave pretty quickly. So we need someone to talk at the next meetup. It can be a talk about anything. Has anyone done anything to do with performance in the last month? You're in the right place. Has anyone made a website in the last year? Are any of your websites slow or fast? Oh, Dom, you want to talk on the 1st of August? Exactly, I just want someone to talk. We are more than happy for first-time speakers. You never have to have had any presentation experience before, and we'll help you with practice presentations and working with your slide deck and getting you up here and talking in front of a really warm and friendly audience. Look around, it's all men, unfortunately, mainly, but very friendly. So we encourage you to bring along all your friends and colleagues and talk about stuff that's interesting. And we find most things interesting because we're geeks. So please do get in touch. You can go to LDNWebPerf.org and get in touch with us to talk about what you might want to talk about. So with lots of further ado, I would like to introduce Jonathan. So has anyone met Jonathan Fielding before or seen Jonathan talk? A few of you. So he's the engineering manager at an agency. That agency is called Beamly. And his talk today, unless I've really misunderstood it, is about taking the kind of principles we think are great for making fast websites and delivering them at scale. So when you're delivering multiple websites per month, how do you get these best practices baked into your process and get the right tools and people in the right places to make sure we can keep things fast especially when you're on budget pressures and time pressures. Is that about right? Awesome. Just rewrite the whole talk now. So I'm going to run away and turn on Jonathan's mic, and he's going to get his silly USB-C touch bar thing to connect to the projector. Cool, go.
Hello. But if anyone knows me, they'll know I speak quite loud anyway. Cool. So it's a shame Perry couldn't make it because he's going to miss my beautiful slide that spent ages making pretty last night. Because obviously we care about pretty slides. So yeah, I work at Beamly. We are a marketing agency, but we started off as a product company. We started off actually as a social network around TV. That failed, but we actually did one thing right, which was marketing ourselves. So as you do, you pivot just as a startup and become a marketing agency, and then we started building. We then got bought out by Coty, which is a huge beauty conglomerate who like I think they're third biggest in the world. So they have brands like Rimmel London, CoverGirl, Max Factor, Sally Hansen, amongst others. So so yeah, we spent some time working with them now, and this talk is about one project in particular. So yeah, I'm an engineering manager, so that means I'm not only responsible for delivering these websites, I actually have to worry about the teams that deliver these websites. I wrote a book on responsive design a couple of years ago, and of course, I'm just here for warm up the pizza, which is why you're all here. So today we're going to talk about processes in the context of a project at Beamly, using it as a case study to show how we're able to produce performant websites consistently. So just over a year ago, Beamly wrote a report for our prime client. The report documented the problems with existing websites, including taking a snapshot of what the performance of their websites were like versus their competitors. And one of the things that were highlighted was the poor performance of the brand's websites. To fix this, what we did was we took a two-pronged approach. One that it was aiming to make improvements quickly, and another to make long-term improvements that'll last for the length of these websites. So the first of these was to take over the hosting of existing websites. Previously, they had been hosted by an external company. So we brought that into Beamly. We moved all the websites to use HTTPS, implemented a CDN, and started using Google PageSpeed as a plugin for Nginx, I think it's Nginx, to actually then optimize the website on the way out, which got us a huge way into a huge way forward to having more performant websites. But the fundamental problem with these websites was they were built poorly, and this is due to the people who were building them being given the piece of work to build a website, but they didn't have long-term interest in that website because it was just a one-off project. So the second prong was to deliver a platform for a next generation of performant websites that would evolve as the clients became more digitally focused. So this is a company that is really interested in becoming more digitally focused as time goes on. The company acknowledged that the brand sites were an important touch point, as it not only allowed them to get first-party data about their users, but to also develop a direct consumer experience for commerce. They're also aware that the websites are reflective of the brand image and could affect their reputation. So in order to actually prove what we were building, we actually set out to build 6 beauty websites. We wanted these websites to look beautiful, to look unique, and most of all, really show off what the brand was all about. And beyond being a beautiful website, we want the sites we build to be functional. In that we want the users to be able to find the products they were interested in and drive them to a sale, whether that be on the site or externally. And of course, we're all here to look about performance. So the website had to be fast, because historically those websites are slow, especially on mobile. So as we're here to talk about performance, let's have a look at how we define fast in the context of a beauty website. So I wanted to start this section of the talk with a statement. A typical beauty website is not very performant. However, this is a very broad statement to make. So what I wanted to do is look at some data, but what I mean is not performant. So to start with, I found 15 popular beauty brands and put their URLs into a web page test. These are not just Coty brands, these are across the industry to get a good idea of what the industry is like, not just Coty. So this is the loading. So what you'll see is some of these websites are really slow. So this is a slow 3G connection on the Moto G, running in duals, and it's still loading. What we're not going to do is we're not going to hang around for Mac Cosmetics, because that takes over a minute to load. The problem with this is while it shows us visually difference and makes us laugh about how bad they are, it's easiest to benchmark against these improvements with metrics. And Andy's in here to hear this shout out, because I use Andy Davies' tool, web page book tester, to actually test these, to test a lot more websites.
Anyone else use these? It's the most amazing thing. You can submit hundreds of tests, web page tests, public or private, collect all the results back into a spreadsheet for everyone.
You ruined my talk. Thanks for talking about it. So I use it to run 40 beauty tests and 40 beauty websites.
Only 40, you can do millions.
I could do, but then I'd have to find millions of beauty websites. And I was already affecting my Google history by looking at beauty websites. So, well. Anyway, so I ran on 40 websites, and I actually made some improvements to the spreadsheet, but I don't know how to raise a pull request on a Google spreadsheet, so that's what I'm not doing back. So I made some improvements to the spreadsheet to allow me to get my data out easily. So I took this data and got the median for the start render time, how long it was until it was visually complete, and the number of requests the page made. This isn't too bad, I guess. Start render time. I mean, this is on a slow 3G connection on a Moto 4G, so that's a slow device. But visually complete in 25 seconds. I'm going to get bored if I look at those, aren't I? So, and then the average number, the median number of requests is 102. Now, this one that I found more surprising. So what I did was I looked at the HP archive. HP archive data normally is in averages, and I wanted to use medians because I wanted to try and exclude some of the outliers. So I used a BigQuery to look at the data from June, and I then got the same data for the beauty industry. So the median amount of imagery for a normal website is 789 kilobytes. For beauty, it's 1,471. Which I guess is a visual website. They're trying to show you products. So if they're loaded well, that's not too much an issue. The CSS one was the biggest percentage increase, though. The median website has 23 kilobytes of the CSS, but most beauty websites are around 140K, some a lot more. So there's no metric in which we can call this website performant. We compared everything, and we're worse than the industry averages. And the industry averages are bad, so we're worse in every single way. So having identified some metrics, we can come back to these later and measure the success of the project. So having done some research into the state of beauty websites as a whole, it's important we understand the objective of these websites so that we can understand what we should be optimized for. So there are two key types of websites in the beauty industry. The first is the brochureware site. So the aim of a brochureware website is to tell the customer about the different products the company offers, and it links out to external retailers. The second is an e-commerce website. So an e-commerce website It's just like Amazon's trying to sell you products, and you go add things to the basket. But both in the beauty industry, especially to market themselves, they have a second function, which is brand awareness, and they do use a lot of content marketing around the brand. So like how you apply lipstick, how you can get this celebrity's look. So this sort of content also features prominently on the website. And one of the aims of the website is to get first-party data so we can know more about the people using the products. And obviously, we need to understand what the definition of performance for these sites are, because this leads to allow us to start determining the objectives of the site. And ultimately, for websites that expect to have a high bounce rate, you should focus your time on getting the first page load right. However, if the website has a decent number of users to go into the second page, you should then start focusing on that second page. So the objective of these beauty websites is actually that first page, because we've got a lot of people that are coming from Facebook to look at how to get this new look. So the objective here was to focus on the first page load. Of course, if you optimize for first page load, your second page load isn't bad, but because that only benefits to me if it's the second page load. So it's prioritizing those things that will affect the what's going to benefit your user most. So first page load was for us. So with a clear objective of what we want to achieve with these websites, we booked out an area in a local pub and had ourselves a applying session, because that's what we do as a product team. So the aim of that session was to actually to define a set of principles that we wanted to follow, but which would allow us to choose our technologies. So one of the key guiding principles we came up with, that we shouldn't have to deploy an entire stack for every client. So you might share a different presentation layer per website, per client, but the actual stack that does the content processing should be the same. And that means you can make a reusable platform for managing your content, which can be optimized for performance. We also wanted to ensure that if we went to a way of doing something, we only did it once. So this would be the case that how we dealt with single item of content, to taxonomies, and even user management. And we didn't want to be afraid of using things that were not invented here. So we thought it was important to avoid getting in a situation where we're suffering from not invented here in Instagram. And in every technology choice we made, we need to consider the impact on our users, the impact on our developers, because of developer experience is important, but also the impact on how the client can update the content. So having defined our principles, we then took a look at the different solutions that are available to us. We considered whether it was a good idea to build something bespoke, or whether we should use CMS such as Drupal or WordPress. We also then considered, what if we combine technologies? We don't need to stick with just using. We don't need to just build a WordPress website. What if we combine WordPress with something else? So because the client was familiar with Drupal, we chose to use Drupal as a CMS. The CMS was not serving content. All it's used for is managing content. We then built a content pipeline that would take the content from an event submitted by Drupal and then store it in Elasticsearch. A content service, which is a node, would then be able to enable us to retrieve this content. And finally, we built the end website in Node.js Express. This allows us to make really performant presentation layers. And in front of that, we had Fastly. Next up was to look at how we built our front end. So we started off by looking at off-the-shelf open source projects. So often these front-end open source projects sit in two camps. We have our libraries. The first of which might be something like normalized CSS. So that would set the default browser state, or provide a set of standard animations like animation CSS. From a JavaScript point of view, we might use something like Redux to manage the data of the data user across our front end. We're using query to simplify DOM selection. At the end of the spectrum, we have frameworks. So in CSS, we try to cover all standard use cases for CSS. The majority of which follow a common established architecture. They provide the foundation of CSS, such as buttons, forms, and table styles, and they offer a buffet of components, such as headers, navigations, like carousels. We also have JavaScript frameworks. So these help us architect our code so it's modular, reusable, and readable. But I really like this illustration from Jake Archibald, where with a framework, you're often finding parts you need as you go along, but you're not using every little bit. Whereas the way I like is I get to a problem building my website and add a library. But I'm not adding something like jQuery, I'm adding something like Query, which is a tiny library. So I'm assembling a group of libraries as I go along. So if you're building a web app, a framework will solve a lot of problems. But these are building beauty websites. So when it comes to our CSS, we did not use a framework. We used normalized CSS. We then built a Beamer base that pulled in our existing grid system, standard buttons, standard typography rules. And then we built individual components. Now, each of these components is a separate repository in Git, and actually is installed as a separate NPM module. This means that rather than like a big framework where you have to go, oh, I have to comment this out, oh, I don't want that, I don't want that. I can literally go npm install this, and it's available to me in my code base. So at this point, we spent this took about 6 months to get to this point, and then it was actually we built these 6 websites. So we started to do some hiring. So at Beamly, like I said, we've got a product focus within our teams. So we use the approach of having a UX, design, and developers all working really closely. Every member of the team had a technical interview. This is because we believe that if we're all able to use the same technical language, we will deliver a better final product to our user. We ensured website performance featured prominently in these interviews, probing to see what they knew about areas such as performance budgets and tools for measuring performance. So from a developer point of view, we asked them, tell us how you ensure a website is performant enough, expecting that they'd come back with saying, these are the tools I would use to test it. I would use lazy loading. I would check it in Chrome to a timeline. They would tell me what things they should do and what to do. I was hoping they'd mention performance budgets. No one did. So, but from a designer point of view, we asked them this question, which is, tell me how you consider performance during your design process. Probing along similar lines around performance budgets, but we also asked them how they would take into account techniques such as lazy loading in their designs, because it's important to have this as part of your UX up front, rather than as a let's add lazy loading as we're building a website. But what I want to stress though is we didn't set out to hire performance experts. Our interview wasn't focused on entirely on performance, but we wanted to hire people that thought about performance, not as an afterthought, but as they were starting to conceive the website. Having built out our cross-functional teams, we then started the process of pulling together our wireframes. So at the start of our UX process, we introduced the team to performance budgets. So a performance budget is a goal that guides design and development. It gives us a tangible way to talk about performance. And this is way better than I could say it. So I want to quote Tim today, which is, the purpose of a performance budget is to make sure you focus on performance throughout the project. The reason you do trouble in the first place, though, is because you would build a site that feels fast for your visitors. In order for you to determine what the performance budget should be, though, you need to determine what you're going to measure. So there's a lot of things you can measure, but we chose to use milestone timing. Milestone timing uses time-based metrics such as load time, content is loaded, and in our case, time to be interactive to measure what time is load. So there is a maximum time it takes to get to our, therefore the maximum time it takes to our milestone forms our performance budget. So back when we started talking about this with our clients and wrote our statement of work, we agreed with them that we expect our site to load within 5 seconds on a slow 3G connection. That was a benchmark we set. It wasn't a, we're going to hit 5 seconds. We were aiming to get lower. But that means that when you start, when you take what slow 3G means, that if you look at web-based tests, it's 96 kilobytes. So when you do 96 kilobytes times 5 seconds, that to be interactive, you've only got 480 kilobytes. So, and then with that 480 kilobytes, you just split it across your assets. So because as I mentioned, we like to put a lot of this is content marketing, you get a lot of articles, and a lot of these articles can be quite long. So we assigned 30 kilobytes to HTML. Then for CSS, we understood that a beauty website does use more than average amount of CSS because of the stylistic approach they use. So we assigned 40 kilobytes CSS, and then because we understood that the reason the JavaScript was so heavy on these websites wasn't because they needed to have such heavy JavaScript. It was because they were using libraries like jQuery. We decided we would not use that sort of library, and we'd only need 50 kilobytes of JavaScript. But the performance budgets are flexible. So the design team suddenly flag, I want to add a font to my website because it'll add emphasis to the brand. So what we can do is we can then start adjusting that budget. So we assign 60 kilobytes of fonts and then take it away from the imagery. And it's important to know the budget only covers the data required to reach our milestone. So you can therefore load more content later using lazy loading. And even any crazy interactions you want to add, you can add them later. So experiment with different performance budgets. So a performance budget is about reaching a correct balance. It therefore makes sense to experiment with different performance budgets to see what suits your needs. And creating that performance budget should be a collaboration between the various stakeholders. So one such tool that helps you do this is Performance Budget IO. So the tool focuses on quantity metrics, such as your time to be interactive. So what you do is you enter your number of seconds, and then you select your connection speed. So these are all the same connection speeds that web page tests suggests. You then get provided with sliders. So it tells you your performance budget is 480 kilobytes, and it gives you the opportunity to slide up and down to work out a balance that you feel feels right. And then when you finish, it actually gives you a nice printout of your budget, but also does some it works out like how long it should take on different internet connection speeds. It's important to note, though, that these performance budgets don't take into account things like latency. So they vary, but it's a good way to understand how your website will load on devices. So once we're set up on our budget for our site, we can then look at the techniques we can use to achieve it. One way is to load imagery so that the browser focuses on loading images that are in view first. So I'm briefly going to cover moving from design to development. So the first step is to define the acceptance criteria for the developer to implement. As part of this, you should define the components that make up the page. Because what you can do with that is carefully consider the performance cost characteristics of each component. So if the component is a hero, for example, and it has a big background image, you can consider how that loads. Is that image at the top of the page? Do I need to load it straight away, or is it a hero that features further down the page so I can delay it? Do I want to provide a different background color to show there's some content going to arrive, and that sort of thing. And then throughout this, we then develop some pair with the designer to validate the way in which the site prioritizes the content it loaded. So repeatability versus uniqueness. So building a large number of websites, we wanted to avoid repetition in our work. And to achieve this, one of the things we did was we wrote a lot of Express middleware. Express, for those who don't use Express, Express allows you to add a functionality that will fire before each route, called middleware. So some middleware we wrote was to handle file provisioning. So we heavily cache our CSS files, and then when we need to start a new version, it would automatically add that revision number through and apply it in the middleware. We also had middleware for setting storage keys. So if you're using a CDN, you can identify each piece of content on a page using a key. So then if when you want to invalidate that piece of content, you can say, I want to invalidate every single page that has this piece of content, rather than having to invalidate everything, because your content could be on different pages. We also had that CSS components, so they were built to be reusable across every project. But there's a huge amount of stuff you might want to do that's unique. So each site has a unique performance budget. This gives the designers the flexibility to add more fonts for brands and imagery, and more fonts for imagery for others. There's also important to note that if something is if you're unsure if it's something that's going to be shared, build for one site and make it generic later, because if you try and make something generic to begin with, you end up with not covering all the different use cases that or you guess at use cases, and you can even bloat your code. So if you assume that it's going to work these two different ways, and then you bloat your code with that, and then if in the future you then find, oh, it's not used both ways, I only use that one, I've got all this extra code for the other one. So aside from the code that we build ourselves, we often have to implement third-party code, which we have little control of. These third parties can have a huge impact on the performance of our sites for our users. And there's 3 different kinds of integrations that we did. So the first of which is the age-old implementing third-party scripts. So in order to do this, we aim to load our code asynchronously. But sometimes simply adding an async attribute to a script isn't possible, or because they rely on some of the code to the page. So we had to do some tricks like once that script's loaded, have an unload event that buys a function that has like some code. And actually, one of our third parties, we found as soon as it loaded, it downloaded, showed loads of images, because it was a curated images from social media. So and it was severely affecting our performance. So what we ended up doing was writing some JavaScript that would add that script to the page after everything else had finished loading. So that because it was at the bottom of the page, so there was no benefit for the user of that executing straight away. It's also appropriate to look at proxying some of these third-party scripts through CDN, because especially if you're using HTTP2, where you have where everything can come over one TCP connection, you have there's a benefit from everything coming from the same host. So an example for us is the Polyfill service. So obviously that's developed here by the FT, and it's a really valuable service for providing polyfill browsers for features. So especially if you're building websites that performance and using browser native APIs, the Polyfill service is great. But the problem we had was when we started testing, we saw that it was delaying the extra TLS connection on a slow device like a Moto 4G on a 3G connection was taking about a second. And because polyfills are required to render the page, because they are the picture element, HTML elements, right? So what we ended up is a blocking request. So we moved that onto, we proxy the Polyfill service, and therefore we can get that loading a lot quicker and remove that extra second that we were blocking the load of the page. If you want to know how we did that Polyfill proxy, we use Fastly, but I can talk to people about it afterwards. The Guardian did it around the same time as us as well. Implementing a third-party API. This actually, we went live with one of our websites today, and this is actually one of the things we had a major problem with, in that third-party APIs can be slow. And we actually had the problem today that we went live with a website, and the third-party API, because we were doing requests on the render, the first time that page was loaded, the CDN didn't have it in its cache, and the request to this third party was taking too long. So if you're implementing a third-party API, it's important that you know the SLA for how long a request should take. B, you put failsafe in. So if it's a server-side third-party API, you know that after a second bail out, and then just render that client-side instead. So it's third-party APIs, even on the server side, can have huge impact. The third one is we had to implement a wrapper around the server-only API. So we had to integrate with an email subscription provider, which we won't put a name, which only providers with a poorly implemented API that can only be used from the client side, so from the server side. For this API, we didn't want to integrate it directly with our presentation layer, because that would affect the performance of our presentation layer, having to handle email requests. So what we ended up doing was we had to develop a proxy microservice that would the user would enter an email address, it would go to our proxy service, get sent on to the third-party API, and then bubble back up. So we built these websites, but we made some missteps along the way. So one of the things that we didn't communicate very well to our entire team was how cache headers would be handled. And there was the assumption that by one of our lead developers was that they'd be applied somewhere else in the stack, so he didn't have to worry about it. He'd previously used Nginx in front of Node.js, so he applied the cache headers there. However, at Beamly, we run Node servers, and then Fastly connects directly to the Node servers. So we had to later go back and add those cache headers in. Another mistake we made that one of the websites made was they lazy loaded all the images. So what this meant was, until our JavaScript had not only downloaded but also parsed and started running, there was no images. So from a loading point of view, it delayed that first image being ready. And then we had a request we needed for a site to load. We mentioned this anyway, and proxying them with a shared host fix it. So yeah, having stuff like that blocking, because it has to be blocking, proxying solves that. So monitoring for changes in performance. So we've gone to great lengths to try and build teams that can build performant websites. We've gone to the lengths to test these websites with tools like web page test. We've talked about performance budgets and put a lot of effort into these sites. And then someone comes along, adds a new component to the page, and it's all for nothing. So when these sites are done, we don't want to degrade our performance. And it's very easy. So easy to blow your budget. So a new component in the page might add new CSS. It might add a JavaScript. That component might even bring in a library itself, maybe within a whole Lodash. It can have a really big impact. Or your client make big changes to content. So this is a common one that your client might not be aware of image compression, and they might upload a 20 meg PNG to the homepage. And while you can minimize that by obviously blocking PNGs and using ends, they might find a way around that. So it's important to be able to keep testing this. So to prevent this, there's a number of tools you can use to manage your budget. So just for the component change, as part of our continuous integration, we test the performance of our website. So if someone adds a new component to the page, and it starts failing our performance budget, then the continuous integration should fail. You shouldn't be able to deploy that to live. If in the content case where obviously it's not deployed, that is required to get content live, you can use a tool like SpeedCurve. So at Beamly, we use it on preset intervals, and it's every day at 12 o'clock, all our websites are tested. So I'm just quickly going to go through some how it works. So you add a site to SpeedCurve. We can then configure the checks, budget, so it will alert you when you go over a certain budget, and you can even set up notifications. If we go to the site tab, we can see the test being run, and you can see right now that was 2.8 seconds start render, and budget completed in 7. And then you can have it post into Slack. So we use Slack at Beamly. as a way to communicate, but we also use it as a way to integrate our tools. So all our monitoring posts to Slack, and now all our performance budget failures post to Slack. So the results of our project. So at the start of this project, the client website looked like this. It took just over 11 seconds to start render. This is where we need elevator music. I always imagine elevator music when you start around waiting. But it's slow. And then also the JavaScript's doing stuff, so it's like, oh, a carousel, so I need to start loading the next image, and just slow. So today we launched their new website, which starts to render in 1.4 seconds, and is ready to use within 4.5. And I say ready to use, that's when everything's ready. So as you see, that's just by rebuilding the site, we've gained a lot in performance, and there's so much more we can do. We're going to start using more sort of like HTTP push, which will hopefully make things faster. So what I did was I compared the Medium V2 website with the CoverGirl website, and yeah, the CSS is a bit under budget. But what you'll see is, yeah, the images, we're roughly on the same amount of images when the page is fully loaded. JavaScript, significantly less. I did exclude the polyfills because polyfills are only downloaded in certain browsers. Most of the polyfills typically aren't downloaded on mobile because they aren't needed, and Polyfill Service will only send the polyfills that are needed. So I excluded that because that was there. Fonts, we were very strict with how many fonts they implemented. We were like, you don't need 50 different like weights. You can like have a title font, maybe a body font, and assuming the license lets us, we then stripped out extra characters we need. I look at CoverGirl's site is available in different locales, but they're all English, so you can strip out a lot of the front characters that you wouldn't expect that you don't see in English. And it's a 67% less fonts. And CSS, it's got the same level of detail as the old website. It's got the same level of actually, it's richer. If you look at this website, it's a richer experience. It's a much nicer experience. I'd say 85% less. This project is still ongoing. So this is a multi-year project. We started working on it last year, and over the past 12 months, we've obviously learned a lot, but we know we can learn more. I mentioned earlier that we completely prioritized the first page load, and it did. And obviously, the second page load is fast because it's caching in the browser all the assets. But there's a lot more we can do with a service worker and stuff. So we're going to start looking at second page load more. And as the project evolves, what we want to do is not just say, these are our technologies we've chosen, they're performant, let's stick with them. We're going to say, okay, so this new technology come around, developers like it because of X. The performance side of it likes it because of Y. And then weigh up what technology we use. One example is, so a year ago, Preact wasn't that big. It had some users, but now it's becoming more of it in its own. It's pretty tiny. We're currently using Hogan.js, which is a templating engine on the front end anyway. So if we swap it for Preact, we're probably going to gain a K in our JavaScript. So we're going to look at that soon. So summary. So performance sites provide a better user experience. I think we'll all agree that watching that video of all those beauty websites loading was not only laughable, but as a user, that's painful. We should therefore be ensuring the performance of goal is a goal of every website we build. And for that, you need to get the stakeholders on board, which will actually form part of your SOW you form with your clients. And yeah, building one performant website can be a challenge because you sit there optimizing it and you sit there like trying to work out, oh, why is it doing this? Why is it doing that? But if you learn and building multiple performant websites at once makes it impossible, because how are you going to get the performance experts to look at all these websites at once, right? But if you iterate a process that everyone can follow, and you get to a state where you're sharing code, and you can start delivering performance websites every time. So of course I've got to thank my wife for watching these slides so many times and they weren't this pretty to begin with, so they were more painful to look at. And thank you. Any questions?
First question, did your performance numbers, just the simple stats in, was that before or after gzip?
All our stuff was using gzipping.
So you mentioned at the start of the presentation about agreeing either load time or performance budget with the client. So towards the end of the project, the client comes along with some crazy component idea or new feature. How do you handle that conversation and say, hey, look, you're going to need to lose the carousel to get that on the site?
So part of that is down to data, right? So we use a tester over everything we implement. So to get to the site, it's at the point where we're building something, we've user tested it. So firstly, you have to go through user testing and see, is there a benefit to this? Before we even start considering what the performance impacts are. Then we're like, okay, so these are the performance, so it's gonna have this impact. What if, can we adjust how we do our imagery slightly? Can we, would you sacrifice one of your fonts maybe if you want to get that feature? So it's just kind of balancing it. Can I defer that feature? Is that feature at the bottom of the page? So is it like adding 100 related articles? Can I defer that?
I love the idea of a client saying, I really want this feature, but can you test it on our users first? I've never had that.
Sorry, we've because we're owned by our client, it's kind of helps as well. So yeah.
Hiya. So you mentioned briefly about your CI tooling. Could you perhaps go into a bit more detail about that? Is that at a PR stage? So if I push up some extra JS, how do you actually diff that against your budget that you mentioned?
So we use web page tests to run the tests, and to do that, I have to have a URL that's accessible. So at the moment, we don't have the ability to spin up instances based on a pull request. So no, we don't run those tests on our websites on a pull request, but our actual components, their style guides are just Jekyll. So we do static websites. So those we can use, we can throw to a web page test.
Yeah, we had the same thing where we tried to use web page tests in the PR, but we also then found that the averages of the results we were throwing up weren't quite within the benchmarks of what we'd expect. So we kept getting fluctuating. We'd run it 3 times, say, and we'd get fluctuating results, and then we could never provide benchmarks to exit on CI with red if something like that happened. So yeah, I guess we're not the only ones who have that problem.
But yeah, actually running it against staging once staging is deployed is most is what they do on actual websites, and that seems to work quite well. We actually go script it all using Ansible.
So taking multiple tests from web page test and the median of that tends to be interesting depending on what environment you've got web page test running in, especially if you have multiple test agents. If you have 3 test agents running on 3 test machines with different ISPs behind them for international kind of nodes, then it's going to get messy. So I think people are moving away from Phantom.js to Chrome Headless with that kind of task. So in CI, Chrome Headless is pretty low resource, which means you can run it in a Docker container on a machine sitting around, and you tend to get all the metrics you need from the DevTools API.
Actually, his question was the same as mine, but as an extension to the answer about the testing thing, the other thing you can do is run the unchanged version as well as a set of tests. So actually, you then take the delta between the, so you get to eliminate what is the current environmental differences, and say what's only the difference between the released code, hopefully.
Keep it control. Simple. Any more questions?
Hi. You mentioned that you had a huge improvement about the CSS loading. I'm wondering what was your approach actually to have this kind of improvement, like, I don't know, if you just refactor it, or if you refactor and cut it, or you maybe load it asynchronously?
Well, so at the moment we're currently loading all our CSS in one file. We keep it all as small as possible. We use BEM as a name, it's like obviously namespace components, which actually encourages you not to write with stupidly long selectors, like really long, which actually you see a lot on these beauty websites, lots of really long selectors. We avoid using important in our code, and if you look in a beauty, these websites, they're like, oh yes, I'll override this here and I'll override this here, and the whole cascading and importance obviously is extra code down anyway. But yeah, we have one CSS bundle. I mean, that's a feature improvement that we can start separating stuff out. But we have one bundle that is small. We use BEM to namespace. We keep our selector small. We use linting rules to say, oh, I want to only have like 3 BEMs deep, whatever. We also have what was I say? So we also have post CSS tasks. So stuff like you have the standard ones like adding all the browser prefixes, which obviously adds more. But we also have things like combine all the media queries, because throughout my code I've declared this media query 100 times, but if I combine them into one. The issue with that is obviously it can affect specificity, but we've not had that many issues with that.
Cool. Any more questions? Yes.
So I will just speak up. On the same topic, have you considered doing the styles above the fold, just the section that you're displaying?
Yes, we have, but it's time. Obviously, the time to invest into doing that, we haven't had yet. We also are using HTTP 2, so it's coming down the same TCP connection. We're going to use, before we actually get to the critical CSS type of approach, we first want to get HTTP2 push working anyway, so they come down at the same time anyway. Again, our bundles are tiny, so it's not like we're downloading a 100K CSS file, downloading to say 20K. So the critical CSS is going to be bigger anyway. So it's something that we plan to look at to see if there is a performance improvement, but it's low priority because we've got all these other things we can do. It's about prioritizing your performance things, really.
Just for my curiosity, what was the 96% of JavaScript?
Libraries, duplicate libraries. It's like multiple versions of jQuery, because who, never mind, multiple versions of jQuery. Yeah, and using frameworks for framework's sake. Like, oh yeah, let's use Font in new framework. Let's use multiple frameworks. That's a great idea. We're using required.js. So like, if we use multiple frameworks, they're not going to clash with each other because it's required. Yeah.
So I'm assuming that you're not using any.
Technically, we're using 25 lines of code framework, which is a little one we wrote ourselves. We bind the ES6 classes to the DOM. That's all it does. But like I said, we're going to look at Preact because we can see some benefits there. We're going to do a spike into it, compare our current file size versus a Preact file size, see what the impact is, because we're going to drop having to have Hogan for templating because we'll be using JSX. So ultimately, we need to start about thinking of developer experience, because at the moment, by using everything as ES6 class, it's not trendy. That's what our industry's right? So no, we are considering developer experience at the moment, and like how we can improve that without affecting performance, so like Preact and stuff. I'm really excited about that spec actually, because of the fact that it's going to improve, hopefully, in theory, it should improve developer experience without the performance hit.
As the pizza is still about 45 seconds away, I want to hijack the first part of that question, which was about inlining critical CSS into the head to improve render performance. And your argument against it was we use HTTP2. Have you tested the impact of HTTP2 on your render performance?
Well, we originally had HTTP1 on the servers because we had a star pattern fastly, and then we had to which was all set up for the old stuff, and then I had to the whitelist this one for use HTTP2, and we did tests like before and after, and there was big benefits of using HTTP2. I think like we shaved a couple of second or two off the load time.
Off your milestone benchmarks.
Yeah.
So it's a 50-50 in my experience. Half of the sites that I've looked at have had a detrimental effect by switching to HTTP2, and some of them significantly.
I guess all ours built the same, so
Yeah, so you're in a really good position.
No, I just want to ask you a question. Have you seen a point of size when that happens?
Point of size.
Or I guess that's number of files versus size of CSS. For example, when life starters slow down.
What's the killer factor?
Yeah, good question.
I'm going to rewrite your question as I've just done. So with HTTP2, the biggest thing we see as a negative impact is number of images. And so if you've got a category listing page and you've got, say, 600 images because someone's clicked show all, and they're all coming down one TCP connection, and your web server or CDN doesn't support HTTP2 priority properly because no one does yet, you've got one connection and you've got 600 plus requests, and your images will have the same priority as your CSS and your JavaScript and your critical functionality. So that's the biggest issue we have. HTTP 1.1 works really well with browsers because they request assets in chunks of 6 per subdomain in the order they're listed in the DOM, which makes so much sense. HTTP 2 is less like, I've got all these requests. And then you get this massive saturation of your network. And you see it most when you're doing synthetic testing, like through a base test, because you've only got, say, cable 5 meg to download it all in, and you see all these connections open.
But
so it's a task.
to counter that though, why would you, as a developer, why would you like, oh, use 6 show more, I'm going to download all the images at once. Why wouldn't you have lazy loading and then load them to the scroll page?
Because what if they scroll too quick?
Yeah.
But then lazy loading, do you do lazy loading or deferred loading? Do you load on scroll? Do you use intersection observer, which isn't supported in all browsers? What about mobile when you've got 3G?
Yeah, we use intersection observer and then
polyfilling.
And then polyfill, yeah.
And that's the best approach. But most people switch on HTTP2 because the CDN tells them they can for free. I don't work for CDN, honest. And then you just assume you're going to get the benefit without testing it and without actually checking what your site, how your site will react and behave.
I think part of that is architecting from the beginning of HTTP2 as well, because like you said, people turn it on because they have it. We actually, we're building these websites. We're going to start architecting for HTTP2 from the beginning because we know we're going to use HTTP2. We know all our users are on HTTP2 because they're on phones, they're on, that have the support, they're on the latest version of Chrome, they're on Safari, latest version of Safari. So we were able to make that decision very early on. The same reason why before Node 6 was LTS, we actually started using Node 6 for development because we were like, okay, by the time this is live, it'll be LTS, so we can start using that. So we planned the technology we used based on what we knew about the next better feature. Yeah.
The problem is a lot of people have to support IE 6, 7, 8 because they have enterprise clients, which is tough. So then you have 2 code bases and you use some kind of forward reverse proxy on your CDN to put some people on your. No. Cool. Well, thank you very much, Jonathan. A round of applause.
Cool.